Here we go. We're going to start with 8.3 proofs with side angle side similarity and side 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 similarity. So this is 8.3 part 2. And again, we'll read through, we'll figure out what we have and how we're going to get to the proof statement. So I have that CD right here is equal to 3AC. I'm going to mark that. And I have that CE is equal to 3BC. Okay? I want to prove that little triangle ABC is similar to DEC. So of course I'm going to write my givens. And you know, I'm going to probably try to highlight. I always like to color code. Okay, so the little one's going to be green, and the big one's going to be red, so that when I write proportions, which you have to remember to prove similarity with either SAS or SSS, what you need is the ratio of the sides equal to the ratio of the sides. In this case, what I'm looking at is these two sides ratios are going to be the same. Then I need to know, am I either going to get the third side or am I going to get the angle in between? And I notice, as always, that these are vertical angles. So these angles here are going to give me the included angle, and that's what I'm going to use to get to similarity. So let's first write the proportions that we can. So we're going to write that CD divided by AC is equal to 3AC over AC, which equals 3. And then also CE over BC is equal to 3BC over BC, which is equal to 3. So both of those things equal 3. That's actually the division property of equality, because you can divide those. And then I can say, since they're both equal to 3, they must be equal to each other. Ta-da! CD over AC equals CE over BC, which is what we want. But that, of course, is the transitive property of equality. Right? They're both equal to the same thing. And then, as I mentioned, I need to use those vertical angles. So angle ACB is congruent to angle, so that corresponds to D, so it's got to be DCE. And that's because vertical angles are congruent. So now that I have the proportion and the angle, I can use the SAS similarity theorem to say that ABC is similar to DEC. So really what you just need to do is meet the requirements of those two theorems and you're good. So we're going to go on to the next one. Again, I'm hoping the color coding helps. So now I've got PR, I'll try to color code these. So PR over MR is equal to QR over NR. So green over red equals green over red is what I am given. What I want to do is prove that angle 1 is congruent to angle 2. Well, in this small green triangle and this big one, you should notice that they both share this angle. Okay, so This small one is PRQ, and it is congruent to the big one, MRN. PRQ, MRN, yeah, just making sure I write the right direction. And actually what that is the reflexive property of equality, because it's the same thing, or congruent, sorry. So in the green one, I have this, and in the red one, I have this. And so I can say that they are similar already by the side angle side similarity theorem. And now, if I know they're similar, then their angles have to be congruent, because that's what similarity is defined as. Same, so the angles are congruent, the sides are in proportion. So since that's the definition, I can say that angle 1 is congruent to angle 2 by, believe it or not, we don't really have, it's called corresponding angles of similar triangles are congruent. If you want to abbreviate it, you can say corresponding angles of similar triangles are congruent, or technically you could say like definition of similarity. So I'm going to say or definition of similar triangles. Okay. Questions? See how you get that? The color coding really helps me. I hope it will help you as well. So this is the long one, but again, you're gonna see this in your homework and stuff. So I want to make sure that I go over it. It's a little bit tricky. That's okay. We've got this. M is the midpoint of JK. M is the midpoint of JK. So what that gives me is these two are equal. I'm going to mark them. N is the midpoint of KL. Here's KL. That gives me that these two are equal. P is the midpoint of JL. Look at that. Okay, so 1, 2, 3, 1, 2, 3. So those are all the same. Now, I want to show that JKL is similar to NPM. So again, I'm going to do my handy dandy highlighting because that helps me. Here's my little triangle. Slippery bugger. And here's my big triangle. It is red. And I want to show similarity. So again, we need to show that we have congruent angles and we have similar proportional sides. So in this case, it looks like we're going to use SSS because you can see that it's all sides. I'm just saying, so that's how we're going to get there. Let's start just by writing our givens. M is midpoint of JK. N is midpoint of KL. And P is midpoint of JL. Now, the first thing I'm going to do is say what I got with those markings. So MN, NP, those segments, and NP are what we call mid-segments. And that was a definition we did earlier. And so if we do that definition, then that gives us other things. So definition of a mid-segment. Number 3. So just follow along. We haven't stepped all the way through it, but that's okay. Now, the mid-segment, once I have that, then that tells me that MN is equal to 1/2. Okay, MN is 1/2 of JL. It also tells me that NP is half of JK. Right here, NP is half of JK, and MP is 1/2 of KL. And that is called the triangle mid-segment theorem. So that was from last week. Okay, now, what you'll notice is if I can get these all equal to 1/2, then they're all equal to the same thing. So this one, I'm going to divide by JL. This one, I'm going to divide by JK. And this one, I'm going to divide by KL, just so you know what I'm doing. So I get MN over JL equals 1/2. This one, I'm going to get NP divided by JK equals 1/2. And this one, I'm going to do MP over KL equals 1/2. See how tricky that is? That's just the division property. But now I have ratios. You see that? Ratios are what I want. And in proportion to. Oh my gosh, this is amazing. They're all equal to the same thing. So if they're all equal to the same thing, then oh my goodness, they're equal to each other. So. And that is the transitive property of equality. So then finally, if all the sides are exactly equal, then I can say that the triangles are similar. This is why I say why. Why can I say they're similar? Because of the SSS similarity theorem. Ta-da! And that's how you use it. That's probably the most involved one we're going to do in this section. And the next one's just a quick 3-stepper. I wanted to make sure we could do those as well. So I'm going to leave that right there. But here I've got this diagram, and I want to show that PQR is similar to PRS. See how much that color helps? You should be doing it too. I can't force you, but you know, I can encourage you 20 bajillion times. Okay, so we're just given the diagram. And because of the diagram, I'm going to write this out. I'm going to say that PQ over PR is equal to 2/3. I'm going to say that QR over RS is equal to 2/3. And I'm going to say that PR over PS is equal to 2/3. Because every one of these is equal to 4/6, 4/6, yeah, and then 6/9. And I just reduced them all in one step. It's not cheating, it's taking a shortcut. And then the second one, if they're all equal to 2/3, you know, so you can infer a bunch of things just from the picture you're given. Okay, again, that's the transitive property at work. Equality. And so last, so this is like a really quick one of this one. So you can say that PQR is similar to PRS. And that is by the side similarity theorem. I told you that would take about 15-20 minutes, and we are at 14 right now. So we're going to go back to their assignment.